Graph 2.2, page number 39 of NCERT. This graph is partial pressure of HCl on y coordinate and mole fraction of HCl in cyclohexane. First, you should know HCl is highly soluble in water but is sparingly soluble in cyclohexane. Another important fact that you should know about Henry's law is P is given by the formula Kh into mole fraction of a gas. So it gives you a relation between partial pressure of a gas versus mole fraction of a gas. From this you clearly know it obeys equation of y is equal to mx, where slope is given by Kh. So it will be a straight line passing through origin. This is what is seen. Straight line passing through origin. And what is the slope of this straight line? The slope of this straight line is Kh. Now what is worth noting is when the pressure is 500 torr, it has solubility of almost 0.010. That's quite low solubility. That clearly indicates HCl is hardly soluble in cyclohexane. And when the pressure is 1000 torr, the mole fraction is slightly above 0.020. That means even after the pressure crosses 760 torr, that is 1 atmosphere, still the solubility is low. But now we have a question: when pressure increases, why solubility of HCl increases? We are all aware that when you have cyclohexane, that's a suitable solvent, and we have a gas which is trapped above it. Now to apply Henry's law, what is the condition required? It is not applicable to highly soluble gases. So that means it is not applicable in case of HCl with water. But HCl with cyclohexane, yes, it is applicable because HCl is sparingly soluble in cyclohexane. Now when you increase the pressure, what exactly happens? Collision of molecule with the liquid surface increases. When collision of the molecule with the liquid surface increases, when collision increases, what happens? There will be more gas molecules interacting with solvent. More are the gas molecules interacting with solvent, more is the solubility. That means solubility increases. So remember, solubility increases. So that's what we understand from this graph, which gives you as a y coordinate partial pressure. This is y coordinate, and mole fraction as your x coordinate. Y coordinate and x coordinate, and the slope of this graph is Kh. Whenever you want the slope of this graph, you can take x1, y1, and you can take x2, y2, and you know the formula of the slope. Formula of the slope will be y2 minus y1 upon x2 minus x1 will give you slope of this graph of mole fraction and partial pressure.